So hey guys, in today's lecture we are going to see the EMF equation of a transformer. For this EMF equation, firstly we need to see what exactly the transformer means. Now basically, what is the definition of a transformer? Transformer is a static device which transfer energy from one side to other side without electrically connected and without changing their supply frequency. So this is the basic diagram of a transformer, where this is the core, this is the primary winding, this is the secondary winding, this is the magnetic flux which is flowing from primary to secondary. So this is basically the transformer's diagram. Now for EMF equation, we need to consider the waveform. Now this waveform shows the actual working of transformer. That transformer starts working from here, which ends to here. Okay, now this is just the referral diagram for the EMF equation. You can see that we reach the value of 5m, okay, at the 1/4 of the frequency. So in a quarter cycle we get the maximum amount of magnetic flux. So let's see what exactly this EMF equation is all about. Now let us consider that N1 is equals to what? N1 is equals to number of turns on a primary. N2 is number of turns on a secondary. Phi-m is what? Phi-m is a maximum flux in a core. F is the frequency of supply. Now, as we know, the flux increase from 0 to its maximum value at 1/4 of total cycle, which is 1/4 of F. You can see it here that we get phi-m in the quarter of the cycle. Okay. Hence, what exactly we required? We need to find out the maximum flux, rate of change of maximum flux. So that will be equals to what? Phi-m divided by 1/4 F, which simplifies equals to 4 phi-m F is equals to what? This is the rate of change of flux, and the unit is Weber per seconds or volt. Now, as the flux is continuously changing, then we should consider a form factor, which is the ratio of RMS value to the average value. And for transformer, the form factor is 1.11. Okay, we got the rate of change of flux. Also, as we know that this flux is continuously changing with respect to their time, we need to consider a form factor where we are comparing the average value and the RMS value. So what we get, that E is equals to 1.11, which is the form factor, multiplied by whatever the rate of change of flux we got. So we got the equation, that is a 4.44 phi-m F. Now this is the actual equation of a transformer. This is the complete transformer equation. Now for us, we need to find out the transformer equation for primary as well as for secondary. So what we have to do, we just have to multiply the primary terms with this equation, and we get the respective value of your side, which is, if we want to find the value of E1, we should multiply this value with the N1, and if we want value of secondary side, then we should multiply this with the N2. So this is basically the transformer equation.